And standby electrical systems, everybody's familiar with this, right? Auxiliary generators, anywhere from a couple kW to a couple meg, depending on the size, okay? That in itself is an entire different maintenance program. Typically outsourced to maybe a Lawson or maybe a Caterpillar, but they'll come in and provide, okay, the systems upgrades. So they, for, okay. Emergency powers is anything to do with life safety. So in some cases, you can have evacuations tied into that circuit, emergency lighting. Standby power is what I consider auxiliary power. Standby power is capable of supporting certain portions of my site or my entire site with standby backup power. Emergency powers, typically for generators, emergency generators, they will not support the entire site. A lot of owners get confused, well, I have emergency power so I can run my entire air conditioning infrastructure in the middle of summer. No, emergency power is exactly that. It's for one, it's for life safety components, okay, for fire horns, strobes, fire strobes. Some cases, elevators, okay, may be connected into that. More likely, E-light, emergency lighting, to allow egress out of a building safely, especially if you're in the basement with no natural light coming in. Okay, so that's going to be the difference between. Standby power is exactly that. I got standby power of 2 meg, and even then, my building takes 5 meg. So my 2 meg is for critical systems and critical components. So primarily data center and pumps and cooling towers for that data center. So I can run on standby power indefinitely as long as I got fuel, right? So when we cover emergency preparedness, part of the maintenance on those standby generators is having a fuel source. You know, where do you get additional fuel? Especially if they're burning 5 gallons, you know, every hour. You know, you got a 100-gallon tank, depending on what the load is in those particular ones, okay? So we'll cover those. Good question, Paul. Thank you. Okay. Uninterrupted power sources. Again, what primarily? Critical devices, computers, right? Meters, sensors, okay? At my facility in Scottsdale, we provide service for NASA. And part of the NASA requirements when we do an equipment test before we ship out the product, once the product is placed, say, on a satellite and it's sent out into space, it's not like we can call it back and perform maintenance, right? I mean, once it gets fired off in a rocket, right, and it's put in orbit and sent to its whatever trajectory is going to be, it's there for good. Okay, very seldom. If they do come back, they don't come back in pieces, you know, where we can actually work on it, okay? So we have reliability testing. So this is how critical this gets. Some cases, the reliability testing may take up to 6 months of a continuous load on that particular device. And we put a chart on it, okay, an electronic device that measures the amount of current. Any spike by 1 or 2 cycles, even a single cycle, and power, it's not even a blink of an eye, is enough to throw that test off, which means it's unreliable. The component's reliable, but the power source was unreliable. So we're into 5 months into a 6-month test. We have a SAG from SRP says 3 cycles. 3 cycles not very long. You can't even see it in lights. But that's enough to throw the test off, which means I got to start that test from day 1 again. So the uninterrupted power source, what it does is it provides me that current when I got sags, in some cases when I got a spike. So it keeps that current at a level. So even though I had multiple sags and spikes, it keeps that voltage at a medium, right? A continuous cycle. Saves me is, imagine having 4 months of labor in a test that went nowhere. And not only that, I can't ship that product for another 6 to 7 to 8 months, depending. So that means I'm out of money. So again, it's going to be a profit. Okay. Wiring material. Okay. What about aluminum? You guys ever hear the horror stories on aluminum wiring? Okay. What's the bad thing about aluminum wiring? Yeah, right? The heat load? Yeah, right? And then oxidation is another item, right? So the electricians of the past, when they had they'd always tighten those up. Right? And they used to think, you know, you're going to tighten and squeeze the wire and it'll pop out, right? But they were doing that for that reason. Make sure the one that's connected, it's got a good connection, and you don't have any air gaps in that. Other item was vibration. Those breaking off. And of course, arcing and flashing And if you think about it, the boxes and houses of years and years ago did not have that. They used to have cloth insulation. And then to make matters worse, there was asbestos cloth insulation. So not only did you get shot, but you also get indoor air quality issues, right? Okay, so some of the wiring materials primarily today are copper. Okay. Wiring is manufactured in different sizes, yes, okay. Different levels depending on what your amperage and voltage requirement is going to be. Insulated with some sort of the thermal process. It comes that way from the manufacturer. So you strip back whatever you're going to tie into your breaker or your device, right? And the rest is insulated. Okay. Romex. Everybody's familiar with Romex, right? House use, different levels. It's like, well, I got some number 12 Romex. I'll go ahead and fire up my air conditioner with it. It's like, not typically. It's not going to be set for that. Okay. Comes in a variety of colors. Hey, what's the colors for? To define the circuits, right? Thank you, Jack. Okay. So green is typically what? Ground, right? Blue, red is typically some sort of line, right? And then you're going to have your white, which is typically going to be a neutral. In regards to that. But again, it's a code, electrical code. So everybody wires it the same way. It's not like if I lose a line, you know what? I'm going to disconnect the white one because it's a good wire. And I'm going to hook it up, right? No, right? So, but again, part of the maintenance routine is to test for those, test for current. That's all part of the routine maintenance. What you're doing in this case here is reliability, and then also for life and safety. Okay. Raceways. Okay. Any type of raceway, even if it's encased behind this wall. I mean, do you ever cringe when people start drilling into this wall? I don't know what's behind that wall. Now, you can run a stud detector. They got conduit identifiers where you can run, see if you got EMT. Or even worse yet, a water line behind that wall. Okay. But one of the items, the what? Yeah, you could. You can also run infrared, in regards to some sections of the wall, see where the heat loads are. Okay. But typically, some sort of wiring. And then, of course, codes, typically it's vertical. Right? So where this is at, somewhere along here is going to be what? The conduit, the source, right? So it's all going to be code. It's not like they ran it this way and decided to go that way, right? So you're going to have some sort of law and order. So when it comes to construction, again, for projects, everything needs to be installed per code. So it's done that way for every building every time. On the maintenance side, it helps us immensely because now we know which way the conduit is typically going to be run. So instead of drilling it right through there, we may go look at it and actually set it to certain levels. Every outlet by code is a certain height, right? So I know if I'll go below that height, chances are I won't be drilling into conduit. Okay, getting back into the code requirements. So again, some of the cases you're going to have, solid and flexible conduit, right? Wireways, cable trays. You're going to have the larger busways. Okay. All mediums, to transport not so much power, current itself, but the infrastructure that supports that power. Okay, and this is typically a J-box. Make those out of plastic? Yeah, they make plastic J-boxes, right? Different types of connections for drywall, metal studs, wood studs, and so on. Okay, when you walk through the old central plant, did you notice a lot of J-boxes didn't have covers? Okay, typically by code, if an inspector comes through, they want covers on all the J-boxes. Again, safety. Okay, safety devices. So if I was a maintenance technician walking through that, I'd count all the J-boxes that didn't have covers. I'd collect 10 of them and go back and start putting them on. Same thing with the wire nuts. Wire nuts that don't. Believe it or not, you'll see wires that have been twisted, but no wire nut. Wow. That one there, you got to be real fast, right? Okay, but that's part of the maintenance program is, oops, you know what, I got to write this up. And better yet, I got wire nuts in my pouch or back of my cart. I'll go ahead and put those on, right? Again, safety. What you want to do is look out for one another. Okay. And grounding is just as important as power, okay, distribution. So a conducting connection between electric circuit equipment and to a ground source. So any type of potential electrocution is going to go to ground. I don't want to be the ground. I'd rather have a wiring or some sort of metal device to become that ground, right? Grounded meaning connected to the earth or to some conducting body that serves in place of earth. They've got grounding rods. And some test facilities require moist soil around that grounding rod. So one of the maintenance, believe it or not, is you take a gallon of water and you pour it down right at the well. You want to keep that soil moist. So it is a good conducting ground, okay, source. Grounding, what I consider your grounding grid in the building. You're going to build those in as you build and pour the concrete. But again, part of that is for, one, grounding protection, and then also lighting protection. So if you do get a lightning hit, you know, has anybody ever seen a lightning hit in the building? It looks like the tilt panel's like, oh, look at that, tilt panel's falling apart. No, it's not falling apart. That was a lightning strike. And you'll see chunks of concrete blown out. And you see the rebar that's exposed underneath it, right, searching for a ground source. So in some cases, the lightning, what is considered the lightning rods, right, top of a building are also periodically inspected and tested to make sure that you have grounding conductivity. And then grounded effectively, intellectually connected to the earth through a ground connection to minimize voltage buildup. You know, rubbing your feet on the carpeting. You ever do that when you were a kid? Have your little brother or little sister do that and go touch the doorknob? Okay, same thing, static, right? Anybody ever do that? Oh, yeah. Oh, you guys are terrible. I would do that. Okay. And grounding systems, solidly grounded means direct and solid connection between neutral and the earth. Okay, so there's no opportunity in regards of dislodging that ground. Ungrounded, having no intentional connection. Resistance grounding, having an intentional resistance connected between a neutral conductor and ground, depending on the application. Primarily, maintenance is going to be the connections and making sure that the connections are tight and have been properly installed. Okay, and reactive grounded, having no intentional reactive element connected between the neutral and the ground. Okay, so these are the properties of grounding systems. But on the maintenance side of the house, what we're doing for is, again, checking the reliability of that grounding system. Okay? The rest is per code. I'm going to have to require to do that. Maintenance takes over, though, to make sure that's going to be a reliable system. Okay? And, of course, with that is equipment grounding, such as air handlers and furnaces and ovens and pumps. Those, in some cases, are connected to a pad. And that pad is actually grounded through rebar down into the, what I would consider the floor system, right? So in this case, it's going to form a bonding system. Okay. Solid direct to ground earth, typically, you know, when you put in your anchors, okay, from within and you pour the pad, okay, you're creating a ground for that particular piece of equipment. Design and integrity are extremely important. Okay. You know, in some cases, depending on the application, the pads can become what? Deteriorated. You saw some of those up on the roof when we went to the older central plant. So in some of those pads that had to exposure to the acid off the cooling towers, sometimes you've got to ask yourself, you know, are those properly grounded? Okay, and do I need to go back and check regular inspections? And just like now, just signs for deterioration. Okay, corrosion is probably the biggest culprit when it comes to grounding systems. I mean, who else is? Well, it's not live. I mean, it has no power running through it. But when you need it, that's going to be the key attribute. Just the last couple of slides here, just energy management systems real quick. Monitor use, right? You know, where the energy is being used and how much throughout your building systems. Okay. Energy management systems. Okay. So just about typically every building that's going to manage its energy consumption and energy costs is going to have some sort of EMS. In fact, Jack, you're working on one now in regards to lighting. Okay. So, but part of that EMS system from a building owner, I like to know where my power consumption is at, where I'm using it, and what my opportunities for cost savings are going to be. Not only that, but I'm operating the facility power systems as efficiently as I possibly can. Okay, so again, monitor energy use throughout the facility to give the facility manager a better sense of where and how much energy is being used. Okay, bottom line. So from a macro high level is you basically review the overall building's performance level. Okay, say for instance I've got a building that's a typical office building, and say I've got 8 megawatt of power in the middle of the summertime, and I run a trend, and I noticed that 5 years ago I was only using 6 megawatt of power. So in the last 5 years I increased my load by 2 megawatt of power. couple things can happen, right? I had an expansion, I added more equipment, but in other cases, I may have systems that are starting to deteriorate. Or I may have had infrastructure upgrades, right, where I didn't compensate for my power increases on my bill. So my energy system is going to let me know, my air handlers, how efficiently are they operating, my pumps, anything to do with what I would consider large consumers of energy and power. Okay? Lighting, how often does my lighting turn on? Do I have sensors on the lighting? You'll be surprised how much power lights alone will take. Then on that, it's a byproduct. The byproduct on the light is not only the light itself, but the heat. So with the heat, I now need to what? Disperse that BTU, right, with a cooling load. Okay? Buildings back in the 70s, basically they didn't have heating systems, but they had lots of lights. The light served as that heating source, okay, back at that time. Now from a micro, narrowing it down, you examine the equipment, electronics, and appliances. So I can see how efficient, not joking all aside, a dishwasher. How effectively am I operating this dishwasher? Am I cycling it during peak periods when I have my spikes, when I have the most cost for power? Or am I cycling that dishwasher during my off or shoulder, okay, power, okay, system? So if I'm cycling a piece of equipment, say in the peak hours, my energy management system will help me control that. So it will prevent that piece of equipment from being turned on. So from a facility manager standpoint, from a maintainability standpoint, is I want to be able to exercise my energy as efficiently as I possibly can. And energy management system is going to be able to do that for you. Okay. Then the main core, okay, I want to focus on an audit, as we mentioned before, lighting, one of the larger consumers of a building's power infrastructure. And a lot of folks think, well, you know, it's the calculators and it's the computers. Not necessarily so. Sometimes you'll be surprised on what's the biggest power consumers. And typically it's going to be the building's infrastructure. Okay? Unless you have some sort of foundry where you have large, you know, ovens and different types of industrial type of equipment. The building envelope, that could be a source, right, of power. Now it's not so much that my envelope's going to make power, but if my envelope isn't sealed, okay, some cases then what I have is I want to keep my conditioned air inside during the summer and my heated air inside during the winter. Well, one of the building envelopes when it comes to the energy audit is how efficient your windows are. Start there. Weather stripping. You know, we get down into weather stripping on an exterior door. You'll be surprised how much cooling and heating comes out of that door when it has no weather stripping. Or in some cases, a window. Okay, that's, you know, some cases, operable window, leave a window open, okay, over a weekend. Maybe in a data center, you know, you're cooling the entire neighborhood. Ever hear that phrase? Right? So in some cases, an EMS will flag you, telling you that typically you should be running at this energy level for this data center at this time of day. You are not. Again, an indication. Okay. HVAC systems, okay, anything to do with power or air distribution and ventilation. And this is what I would consider the customer equipment. Printers and copiers and computers. Some cases, maybe their production equipment, manufacturing equipment would be included in that. So part of the audits determine other possible energy savings. So the first thing you would start with your EMS, determine what are your full loads, okay, for during peak, shoulder, and non-peak, okay, quadrants, okay, in regards to your bill. The next level in regards to your energy audit is how efficient is that equipment rated for? Everybody familiar with Energy Star, right, equipment? So that'd be maybe one of your first tiers. How much is my equipment Energy Star rated? Maybe it's only 5%. Gosh, I said, well, you know, I'll put in a policy. My next set of copiers will be Energy Star rated, or my lights fixtures Energy Star rated. Then you start ratcheting it up. Other large ones would be pieces of equipment that are high consumers of energy. I can't really do anything about that, but I can regulate when they turn on and off. Okay, duct heaters. You know, I'll turn on duct heaters to preheat a building during non-peak early in the morning. But guess what SRP does during the wintertime? They change the peak loads. So going from the afternoon, they go further into the morning because why? They know. While facility managers are notorious to preheat a building, at 4 in the morning. So guess what? My peak loads now start at 4 in the morning. I can't get away from it. So my building envelope now plays a big part on how well I can contain that heat, right? And then if I turn off all the lights because I'm saving energy, what does that do to that room and that auditorium? Now it becomes cold. So that's, you're fighting two, right? So energy, I've got energy management technicians at my facility. Their full-time job, 40 hours a week, if not more, is finding ways to save energy. Different ways to pre-cool or preheat the building, extend that further into the evening, further into the morning. Okay.
Do you guys do solar in your place?
No solar. I wish I could have some subsidies, though, that would allow me to do that, but no solar. Okay. Solar is a great source, but it's just, right now in some cases, it's the cost. Okay. Wind would be another one. But, yeah. Well, believe it or not, I had an idea of putting in, the cooling towers where you got your fans, of putting in a turbine. At the cooling tower, right, to generate some electricity while you're using your fan, so you get some sort of return. But now, they got what they consider coolers, to where you're using say I got an exhaust system, and I'm exhausting. Yeah. So, I have an exhaust system, and in some cases I can use that as a turbine. But more than that is I'll use my exhaust systems to pre-cool outside air. So I run that through a heat exchanger. So I'm exhausting. I can't, because it's hazard. It's some sort of emissions I can't return back into the building. But I can run that air, though, through a heat exchanger and pre-cool my 130-degree air coming in from a rooftop, maybe pre-cool or cool that down to maybe 90 degrees. That way my air handlers and my chillers and the rest of the infrastructure don't work as hard. So there's a lot of neat technologies and applications in regards to that. Okay. You've seen this one before, the infrastructure. Okay, primarily your backbone. Of course, all your devices, anything connected to your EMS, remote stations, and of course your stationary, such as with the server. We saw these with both central plants, and you probably noticed the monitors being able to monitor their equipment. Okay, and then just energy management program. Top-of-day programming is probably the easiest way to capture energy savings. I know you remember this. 10 years ago, we were having the rolling blackouts in the valley. Does anybody recall that? No? We had power grid issues, okay? And what they would call them was rolling blackouts, brownouts. So what was happening in the valley is that we were always subject to have a power outage. So what would happen, SRP would call us maybe 30 minutes before the outage and forewarn, at that time, Motorola. We have to, one, secure the grid, so your block 5, so we're going to go ahead and turn power off to block 5, which includes my facility. It never happened, but that was always that criteria. It was happening in California on a regular basis. They were losing the entire grid. Okay, very cost consuming, and the other one was a inconvenience, okay, to the customers. So what happened is that during that time, we started, our time of day, we would start to idle down our air conditioning, say summer. We start to raise the temperature, say at 4:30 in the afternoon. Well, our employees go home at 4, so they're comfortable up to 4, then we start raising the temperature. Well, when we were being asked to shed power, shed load, we started to increase or move that timetable up. So we started to raise the temperature up, say at 2 o'clock. But since the insulation properties in the building were pretty good, it stayed cool within that office or cubicle, whatever the case is, beyond 4 o'clock. So then we got to be smart. Actually, we started to experiment. We moved that up to noon, right? Then we waited 4 hours. Any complaints? Nothing. Wow, that means we cycled everything down at noon, and we waited 4 hours of off-peak, right? No equipment running. So then we really got bold. Says, you know what, we're going to try 10. Let's do 10 o'clock. So we did 10 o'clock in the middle of July. Trust me, by 1 o'clock, people were calling. Patrick, it's 82 degrees in my office. Can you turn the air conditioning back on? Right? Experimenting. Like, whoops. That says, maybe 10 o'clock's too early. So now our set point now is 12:30 in the afternoon. Sun is set. And primarily sometimes for lunch, but when they get back from being outdoors back into a cool building, I mean, anything cooler than 115 degrees feels what? Feels pretty good, right? So again, these are some of the attributes of an EMS system in helping you manage your energy consumption. At our site, we've dropped our energy consumption by almost 35% in the last 20 years. That's a chunk of change when it comes to power and power saving. Yeah, yeah. So, okay. Again, optimize start time, start top. Okay, yeah. Warm up, cool down, as we mentioned before. Cool down, you want to cool down the building in the summertime. You do it early in the morning as possible. Get it cooled down, especially large auditoriums. Okay, and then back off in the cooling. You do the opposite during the winter conditions. Okay, economizer operation. We looked at these in the outside air economizer and our air handlers using free cooling. So when the temperatures drop down to say down into the upper 30s, and primarily upper 30s, not anything below 30 because you'll freeze the coils. But I can use that outside ambient air temperature to cool my building. And that's the only cost of the fan. So I don't have to run the energy, okay, the highly energy consuming central plant equipment. Heat exchangers using my, I didn't notice those in the central plant as a heat exchanger, but I can use my cooling tower water during the winter conditions to actually cool my process water going through a heat exchanger. Secondary pumping systems in a central plant. Both facilities had those secondary pumping systems where I can equalize and actually utilize my chill water temperature in my loop. Because there's a lot of energy, embodied energy in an entire loop. Okay, I can use that as energy savings opportunities too. And then the plate and frame, as I just mentioned before.